All right, this is the Unit 9 test review number 16. The volume of a sample of oxygen is 200.0 milliliters when the pressure is 3.000 atmospheres and the temperature is 37.0 degrees Celsius. What is the new temperature if the volume increases to 400 milliliters and the pressure decreases to 2.00 atmospheres? All right, so let's get our givens written down. We know that the initial volume is 200.0 milliliters, and we know that the pressure, initial pressure, is 3.000 atmospheres. Sorry, let me write that a little bit better. Okay, and we know that the initial temperature is 37.0 degrees Celsius, that we need to change immediately into Kelvin. So 37 plus 273 is equal to 310 Kelvin. All right, then we know that the volume is increased to 400 milliliters. So that's our final volume. And we know that the pressure is decreased to 2.000 atmospheres. So we know that that is the final pressure. All right. And it says, what is the new temperature? So we know that we're looking for temperature. Okay. We know that we're going to be looking for it in degrees Celsius because our initial was given in degrees Celsius. Remember, though, that when we solve for this, we're going to get it in K, and we're going to have to convert. Okay, so the equation. All right, this is the combined gas law equation because we've got pressure, temperature, and volume all changing in this. So when you look at your equations, the only one that has pressure, temperature, and volume in it is the combined gas law equation that also has number of moles in it, which we're just going to ignore. So we have P1 times, writing the wrong thing down here, P1 times V1 over N1 times T1 equals P2 times V2 over N2 times T2. All right, so when I say that we're just going to ignore the number of moles, we're saying that it doesn't matter because they're staying the same. So since they're staying the same, we can just kind of cancel that right out of the equation and then do our substituting in. And the reason why you're allowed to do that is because it doesn't change. So we don't have to worry about it. All right, so substituting our numbers in, we have 3.00 atmospheres. And then we have our initial volume, which is 200 milliliters. And that is all over our initial temperature, which is 310 Kelvin. Make sure you use the Kelvin amount. Our final pressure is 2.000 atmospheres. And, I forgot a zero on our number over here. Sorry, that should be 3.000. All right, now I have it in there, right? All right, so 2.000, and that's multiplied by our final volume, which is 400 milliliters, and that's all over the final temperature, which we don't know. All right, so cross multiply and divide, or you can simplify first. It doesn't really matter, whatever you want to do. So I prefer to do a little simplification first, and I'm going to do the rest of this problem up here. So 3 times 200 is 600 over 310. And then 2 times 4 is going to be 800 over T2. All right. right, so now at this point, you can do your cross multiply and divide. It's just a little bit easier to get those numbers simplified down first. So that means that we're going to have 600 times T2, and we're going to be multiplying 310 by 800. So 600 times T2 is equal to, and then let's go ahead and multiply 310 times 800, and that gives us 24,800. So that's 248,000. And then we need to do our divide. So cross multiply, then divide. So we need to divide that number by 600 to get our second temperature. So we divide that by 600, and we get 413.3333. This is repeating. All right, now remember I said at the beginning of this problem that because our initial temperature was in degrees Celsius, that we needed to convert back to degrees Celsius once we get this temperature, because this temperature, remember, is in Kelvin. All right, so to go back to temperature in degrees Celsius, all we do is take this 413.333 and we subtract 273 from it. Okay, and when we do that, we get this, 140.333, repeating. All right, so then the last thing to do is look at our significant digits. And our volume, our pressures all have 4, but our temperature has 3, which means our answer needs to go to 3. So our final answer is going to be 140 degrees Celsius, and you can go ahead and put that decimal on there. And that's the final answer.